This is section 3.1 and 3.2, and we're gonna try not to have any numbers in our discussion today. We are remember we're in this math. We're in this like hot air balloon looking, and we're just lowering ourselves down on little bitty sites of mathematics. Okay, so we did financial mathematics, and we're going to do measurement and that sort of thing in a little while. And right now we're just doing logic. Okay, and so we're just scratching the surface of logic and getting an idea about it. And it's kind of fun, except that I will say it's kind of like I'm teaching you English, and I have absolutely no qualifications to do that. So let's see how it goes. All right, it says identify English sentences that are statements. Statements are in using symbols to represent statements. In everyday English, we use many different kinds of sentences. Some of these sentences are clearly true or false. Others are opinions, questions, and exclamations, such as help or fire. However, in logic, we are concerned solely with statements, and not all English sentences are statements. So we're going to have to actually do some homework problems, like the first 8 problems. You have to decide whether it's a statement or not. Now, the way we decide it's a statement is a sentence that is either true or false, but not both simultaneously. All right, sounds good. What is the example of a statement that is both simultaneously? Well, if you look at the textbook, this is kind of fun. And I will remind you that I can come over here to the computer. And we have, okay, computer. Let's see. So if I go to 1332, this is Course Compass, which is different than the Blackboard where the videos and notes are. But this is where your homework is. And if you click on Entire Textbook and you come down here to the chapters, you can read the chapters. And I really like this author, which is why I steal a lot of his stuff. But if you look in here and you go to 3.1, I think it was in 3.1, and he has these, we're just kind of going through the lesson. It's either in 3.1 or 3.2, but it was the little study tips, and he's got these little blitzer bonuses on the side that are really cool. And so here's the blitzer bonus. It says Logic and Star Trek. In the television series Star Trek, the crew of the Enterprise is held captive by an evil computer. The crew escapes after one of them tells the computer, "I am lying to you." If he says that he is lying and he is lying, then he isn't lying. But consider this. If he says that he is lying and he isn't lying, then he is lying. The sentence, "I am lying to you," is not a statement because it is true and false simultaneously. Thinking about this sentence destroys the computer and they are freed. So wouldn't it be fun if someone could go out on YouTube and find that clip for extra credit? That would be cool, and we could post it. We could all watch it. That would add a new element to the lesson. So there's your extra credit challenge for the day. I don't know. The Logic and Star Trek. It doesn't say which. Oh, is he saying? He doesn't tell you, so you have to do some work. Yeah, you'd have to do some searching. You'd have to do some searching, but it could be something that you can handle. Stick it out on Google. All right, I expect an email soon. Don't do it right now. All right, now, okay. So here are 2 examples of statements. London is the capital of England. That's a true statement. And William Shakespeare wrote the last episode of The Sopranos, which is a false statement. Right. So we've got a true statement and a false statement. They're both statements, though. Okay. So I cut and pasted out of your homework, and I jumped around because there's like 28 opportunities for success in your homework, and I don't put all of them on here. So this is number 6 in your homework. It says there are 31 days in September. Is the given sentence a statement? Yes, it's true. It's not true. It is true that it is a statement. It is not a true statement, right? It's false because 30 days have September, April, June, and November. All the rest have 31 except for February on leap year when you have 29 or something like that. Okay. So this is a statement. It's just a false one. What about number 5? What do you want to eat? Is that a statement? No, because that's a question, right? Okay. Now, fortunately for you all, since we're not going to talk about indirect objects or something direct objects and conjunctions and all that stuff, which I did last night with my daughter's homework. I didn't actually do it. I looked right at her and I said, Becky, I teach math. I have no idea. I have no idea what those are. Mom. All right, express statements using symbols. All right, so what we're going to do in logic, we're going to try and get rid of as many words as possible because that's what we like to do in math. So we're going to often use letters, P, Q, R, and S to represent statements. So P or Q. All right, so P represents the first statement and Q represents the second statement. No big deal, all right? Now, then what we like to do is we like to negate statements, okay? So the sentence, London is the capital of England, is a true statement. If we want to make that a false statement, then we just put the not right in there. London is not the capital of England. That would be a false statement. So the negation of a true statement is a false statement, and the negation of a false statement is a true statement. All right? So just a little language. So this is number 8 on your homework. It says, form the negation of the statement. It is below 0 outside. So all we have to do is shove the word not in there, and you should be able to determine that it is answer choice C. It is not below 0 outside. Does that make sense? Okay, here's another one, number 9. Thursday does not come before Friday. Well, to undo the does not, you just take that out. And so we would say Thursday comes before Friday, which is also choice C. All right? Okay. Well, if we want to have some notation for negation, it's like a little poem. Notation negation, it is this little tilde. Okay? So the little tilde is what we use in front of the P or in front of the Q to indicate not P or not Q. It's just language. And so the negatement of statement P is expressed by writing tilde P. We read this as not P, or it is not true that P. All right? So if P represents the following statement, the largest organ in the human body is skin, and you're asked to express the symbol not P in words, then all I want you to do, that notation means I want you to negate that statement. So what would that be? Right, the largest organ in the human body is not skin, which is B. So that's like number 12 on your assignment. Is this fun? I know. You knocked this homework out. Okay, now here we go. Express quantified statements in 2 ways. Now we have something new, but it's not that hard. We're going to talk about quantified statements. In English, we frequently encounter statements containing the words all, some, no, or none. And these words are called quantifiers, and a statement that contains one of these words is a quantified statement. Okay, so these are just a bunch of definitions. All poets are writers. That's a quantified. It's like some quantity, all of them. Some people are bigots. No common colds are fatal. Some students do not work hard. Okay? Using our knowledge of the English language, we can express each of these quantified statements in 2 equivalent ways. That is, in 2 ways that have exactly the same meaning. So you can say all A are B, but a, I guess, equivalent pessimistic way to say that is there are no A's that are not B. So you can say all poets are writers, or there are no poets that are not writers. Those are equivalent arguments. Some A are B, you can say there exists at least one A that is a B. Some people are bigots, at least one person is a bigot. No A are B, so all A are not B. No common colds are fatal, or are all common colds are fatal. Some A are not B, that not all A are B. Some students do not work hard, not all students work hard. Okay. So what we then do is we're going to negate a quantified statement. Okay, so we're just kind of working slowly through. That told you what a statement was. I told you about the negation of a statement. I told you about the notation that you're going to use, and now a quantified statement, and now we're going to negate them. So forming the negation of a quantified statement can be a bit tricky. Suppose we want to negate the statement, all writers are poets. Because this statement is false, its negation must be true. So the negation is not all writers are poets. This means the same thing as some writers are not poets. And we see that the negation is a true statement. Okay, so in general, the negation of all A are B is some A are not B. And the negation of some A are not B is all A are B. And now what if you have the word some? In general, the negation of some A are B is no A are B. And the negation of no A are B is some A are B. Okay? And so let's look at the study tip because he gives us some nice information here. It says, the negation of all writers are poets cannot be no writers are poets because both statements are false. Remember that the negation of a false statement must be a true statement. And so in general, the negation of all A are B is no A are B. Okay, and then we put it in a nice little table where we look at the statement and then its negation. And then he gives you a little study tip where it's along the diagonal is the negation. So all A are B, some A are not B, some A are B, no A are B. Those are your little negations. And so some examples. All humans are mortal, and then some humans are not mortal. See, because we're thinking about The Sopranos, and like right now, that was on HBO, right? Yeah. But now it seems like, at least at my house, the big show that we watch, and I think, is it come on tonight? Is, what comes on? Does anything come on tonight? Jersey Shore. The what? The Office. The Office. Anybody watch any? Y'all don't watch. You get on your phone, you watch it when you want. Vampire Diaries is the have you seen this? I just live with these two small people, and they decide what's going to be on TV, and I'm like kind of sucked into it now. I like Jimmy brought home, so I'm watching a couple episodes. My daughter read the books, and it's actually kind of cool because I have a son and a daughter that they just don't really get along. I mean, I guess that's how it is, but in the Vampire Diaries, there's a brother and sister whose parents are dead, which is always cool because it makes high school a lot more fun. And and they're kind of, I don't know, whatever, they're making it through life, living on their own in this great house, and they have plenty of clothes and money and everything, and no parents. And they're nice to each other, and like the sister worries about the brother, and so that was happening last night. And I said to Becky, I said, "What?" And to Jimmy, both. I'm like, "Why don't you guys act like that?" And simultaneously, but in different wording, they said, "That's a movie, Mom. They're following a script." Like if they were really brother and sister, they'd hate each other. But anyway.
Probably didn't say, well, because y'all aren't dead.
Oh yeah, that would have been nice too. They said the other thing that's funny about the show, because now that I'm sort of into it, is this whole idea of being a vampire is kind of exciting because you get to stop your life when you're looking really good. That seems to be what happens, when you're like just this hot as you're ever going to be. You stop your life. You get to be that forever. You never get old, right? And then the other thing that's kind of a bummer about life is that you like to sleep all the time. We have to sleep. Have you ever noticed it's a bummer that you have to sleep because you have so much to do? But if you're a vampire, you don't have to sleep. You have that whole blood drinking thing that's just kind of a problem, but the sleeping is good because I think if you never had to sleep and you were going to live forever, you wouldn't mind like learning to play the piano or like reading every book ever made in the library. I mean, you would do a lot of things that you're like, wow, I would do that if I had more time. Anyway, but of course, so all humans are mortals. Some humans are not mortal. I'm just trying to make the lesson go a little longer by putting in some, stuff. All right, so some students do not come to class prepared. All students come to class prepared. We know we've got some statements there. Some psychotherapists are in therapy. No psychotherapists are in therapy. And no well-behaved dogs shred couches. Some well-behaved dogs shred couches. And I actually have a dog. When I was in college, it was a boxer, and he was very well-behaved, very sweet. But I came home from work one day, and the whole couch was like, it was one of those foam couches. It was everywhere. And he turned around. They're so cute, and his whole mouth was full of the foam, and he just looked at me, and I was like, So he was a well-behaved dog, but he did shred the couch. So this is a true statement. Okay, so now let's try number 14 in your homework. It says, all people are temperamental. Express the quantified statement in an equivalent way. So now we're just looking for an equivalent statement. Okay, so if you go up here and you can have some equivalent statements. That was a little chart, right? All A are B, and it says there are no A that are not B is an equivalent way to express it. So if we have all people are temperamental, we could say there are no people that are not temperamental. Now that may not be the one we choose, but that's kind of how I'm thinking about it. Is there one like that? Yes, okay, that is choice A. You know, it's kind of hard. It's almost like more fun to do it yourself and then pick the letter than to read the answer choices, because they can be kind of like too many words. All right, now we need the negation of the quantified statement. Okay, remember it's all A are B, right? And if you come up here, the negation of all A are B is some A are not B. So some people are not temperamental. Some people are not temperamental. And that is D. Some people are not temperamental. Do y'all agree? D? Yeah. I got it right. Okay, good for me. All right, now it says, now we can do something new. We're going to learn a new little symbol, and it's an and statement. So what we want to do is we want to put two statements together with the conjunction and the little symbol, remember, because we want to get to math, we have to make things scary. So what we do in math is we put all the secret code in, you know. So we're learning the secret code for logic is the P, which is just a statement, and the Q is a statement, and the little caret, it looked to me like a little carrot top or a little mountain top, that's and. Okay, so the compound statement P and Q is symbolized by P and Q, and it's called a conjunction. And they tell you can remember that this is the and by thinking of it. It looks kind of like an A without the horizontal line, but kind of like an A. Okay. So it's easy enough. Of course, the English language has so many different ways to say the same word. And in the book, he actually even has, I think it's in the next section, he looks at, in section 3.2, he looks at different words and how many meanings there are for that particular word in the English language. So if I go to the computer, like he says here, the word set has 464 meanings. And the word run has 396 meanings. The word go has 368 meanings. If you go to the Oxford English Dictionary, take 343 meanings and stand 334 meanings. Is that weird? So you have to, the English language, when you're trying to do it with logic, is very tricky. The other thing and so that's why on this table 3-4, they kind of take a moment to say, all right, in math, we do P and Q, P and Q. We just do the same thing. Because in math, we're not being vague or trying to be verbose and use lots of different words. We're trying to be very succinct and precise. But in English, it could be that you say P and Q. It is after 5 p.m. and they are working. P but Q. It is after 5 p.m. but they are working. It's the same thing, though. P yet Q, it is after 5 p.m. yet they are working, and P nevertheless Q, it is after 5 p.m. nevertheless they are working. So if we lived in a math world, you would not have problems like this. I mean, you would not have 7 ways to make the ooh sound. Do you see what I'm saying? Have y'all ever noticed how hard it is to spell anything? We've got 2, 2, 2, and they're all spelled differently. Shoe, blue, and foo, and foo, and fooey. I mean, you know, it's just too many ways to say something. Does that bother y'all or no? It doesn't. See, in math, there's one way. If you want an and, that's it, right here, one way. One way to do it. Okay. So number 17 on your homework says, let P and Q represent the following simple statements. P, I eat bananas. Q, it is time to sleep. Okay, write the following compound statement in its symbolic form. I eat bananas and it's time to sleep. Okay, so all you have to do is do the P and then the little thing and then the Q, okay? So just go ahead and, you know, if you don't do the homework, just, I don't know why you wouldn't do that. But let me show you on the computer, if you go into the homework, no, we're going to do some fun stuff, don't worry, it'll get harder. This is called the math palette. So this is where you're going to grab your, I already did this one if I do a similar exercise. The taxes are high and I worked hard. So you would just do the P and then this little guy and then the Q. Well done. Well, thank you. Look, you can even watch a video. It won't be me. It doesn't always come up.
In our next problem,
she's a cutie.
Dealing with
in our next problem, what's she going to do? I can't really hear it.
That have been put together. Let's see the problem.
Let P and Q represent the following simple statements. P, it is after 5 p.m. Q, they are working. Write each compound statement below in symbolic form.
I think you got it. All right, it does get a little bit trickier in a minute, and she's going into a little bit trickier one, so we'll look at that. Just slightly trickier. So you've got lots of help to help you do this homework. Back to the laptop. Okay, I'm not being facetious. We are going to get to like De Morgan's laws and logic statements and arguments, and it's going to be a little bit, it'll at least be interesting to you to see how people think carefully and clearly about the statements that they're making. In this chapter and in mathematics in general, when the connective or appears, it means the inclusive or. If P and Q represent two simple statements, then the compound statement P or Q means P or Q or both. So if you have a joint checking account with someone, it normally says both names, but it'll have the word or in between, and that's because either person can sign or you both can sign. If you get a check and it has the word and in between, then that's it's exclude. You have to both sign in order to get it. So like you always hear about that on the lotto, like that last one where the woman won and her estranged ex-husband was like, what? You know, or no, estranged husband. They weren't ex-husband because that check's going to be to both of them. So it's kind of interesting. But anyway, let P and Q represent the following simple statements. I work hard and I pass the course. Write the following compound statement in symbolic form. Inclusive or has the little V, regular looking V. Okay, so that's the symbol for an inclusive or. So now this is just slightly trickier because we learned the symbol for negation. What was the symbol for negation? It's called a tilde, the little thing. Okay, so I work hard or I do not pass the course is going to be P. The or is the V, but I do not pass the course is going to be a little tilde and then a Q. Pretty fun? Yeah, okay. And see, you know what? If you go and you talk to your, I don't know, significant other or parent or sister or brother about what you're learning in contemporary liberal arts math, if you show them this, they're going to think you're learning some really good stuff. You know? That's pretty awesome right there. Wow, God, that looks hard. Okay, if-then statements. These are fun too. The diagram in figure 3.1 shows that all poets are writers, okay? In section 3.1, we saw that this can be expressed as there are no poets that are not writers, okay? Another way of expressing this statement is with an if-then statement. If a person is a poet, then the person is a writer. Oops. This form of statement, if P then Q, is the compound statement, and the little symbol is the little arrow pointing to the Q. And the P is called the antecedent, and the Q is called the consequent, which is kind of easy to remember to me because it's like consequence. You know, if this happens, then this happens, like the consequence of what's going to happen. So the antecedent implies or leads you to the consequence. And so a lot of times when I'm doing higher mathematics and writing theorems and such, I'll use this symbol and say the word implies. This implies this. Okay, so let's look at it in English. Once again, we're doing the same thing in math, right? In symbols, it's all the same, but we have about 1 million ways that we can do it in English. If P, then Q. If a person is a father, then that person is male. Q if P. Okay, well, that's switching around there. A person is male if that person is a father. P is sufficient for Q. Being a father is sufficient for being a male. Q is necessary for P. Being a male is necessary for being a father. P only if Q. A person is a father only if that person is male, and only if Q, P. Only if a person is male, then, or we don't even say, is that person a father? Okay, so let's practice. Number 21 here, it says, let P and Q represent the following simple statements. It is time to eat. It is time to sleep. I eat bananas. Write the following compound statement in its symbolic form. Okay, if it is not time to sleep, then I do not eat bananas. Okay, so we've got a not and a not, which means we're going to use the tilde. So not P implies not Q. Pretty fun? Okay, and that one's even multiple choice, I think, so, which is good. I like to do them with, I like to just try and figure them out without picking them, so you don't have to type it in, or without looking at the answer choices. Okay, let P and Q represent the following simple statements. You are human, you have feathers. Write the following compound statement in symbolic form. You do not have feathers if you are not human. Okay, so we are negating the have feathers, which is Q. So this is if you are human, that's your P. So P implies, oops, wrong symbol. P implies not Q. Is everybody okay with that? You can't do not Q implies, even though, do you see how my brain, I had to switch it around from the sentence? This is P, and this is not Q. But when you're writing it in mathematics form, you always put the antecedent and then the consequence. So that's why I had to do the P and then the not Q. Yeah, I mean, it kind of feels like not Q, arrow P, but that's not right. Okay. A person is an unmarried male if and only if that person is a bachelor. Okay, this is a new thing that we're looking at, and this is the if and only if statements. And these are very strong statements because that means that P implies Q and Q implies P. So you have what we call a biconditional statement, or an if and only if. And symbolically, we have two ways, or really only one way to do it symbolically, and that's with the line, with arrows on either side. But when you're writing mathematics and theorems and such, sometimes you see if with two F's, and that means it's an if and only if, meaning it goes, it's actually a very strong theorem if this implies this and then this implies that. You may remember that from geometry if you've ever looked at some theorems in geometry. Okay, so again, we have the symbolic statement, and then we're looking at the English statement that it could be, and some examples. So P, if and only if Q, could be a person is an unmarried male if and only if that person is a bachelor. Q, if and only if P, so you can just switch it around. A person is a bachelor if and only if that person is an unmarried male. If P, then Q, and if Q, then P. So then you can do it that way. P is necessary and sufficient for Q, and Q is necessary and sufficient for P. So you're going back and forth. So necessary and sufficient seems to get us to go either, to get to the if and only if. Okay, and then we have a nice little table that summarizes all that we went through. So this, if I were to give you anything to take on this test, this would be sort of kind of what I would be willing to give you, just to remind you of the different symbols that you learn. Okay, so let's look at number 25 on your homework. It says, consider the statements. The tie is black, the hat is brown. Rewrite the statement of, so what is this? This is not P and Q, right? So not P, if the tie is black, what's the negation of that? Just rocket science, yes. The tie is not black. And for this little symbol there, the hat is brown. So that's fun. So this is not P, and then here's your little and symbol, and then that's your Q. Okay, one more or two more opportunities for success. Let's see. Let P and Q represent the following simple statement. P, I get an A. Q, the chair is broken. Okay, write the symbolic statement. P, if and only if, not Q. So, P, which is if I get an A, I get an A, if and only if, careful, the chair is, yeah, because it must be, woodshop class. If and only if the chair is not broken. Okay. Let Q and R represent the following simple statements. Q, it is Saturday. R, we are playing video games. Write the symbolic statement, not Q. And what was this? What's this V? Or. Remember, the and looks like an A, so that's the or. Okay, so it is not Saturday. Or we are playing video games. It doesn't have to make sense. You're just practicing. Taking statements and negating them and joining them and such. Okay, so that's it.